All right, let's look at absorption spectra of the sun. So if you look at the picture that we have right here, that's actually what we would see. So if you notice, there's some dark lines in there, and what those lines are where the elements have actually absorbed that spectra. So this is what we would see, and then this is what we would have as the result. So for instance, when we look at hydrogen, I'm just going to walk through hydrogen with you guys, and then you can do the rest of those elements. So just to use color for this so that it's clear, I'm going to use, let's just use purple. All right, so purple for hydrogen. So what I'm looking for is that if hydrogen has its specific spectra pattern, is it's going to be absorbed at the 410, 486, and 656. So now if we look at this graph down here, which is showing the intensity measured, wherever we see a blip, that's where that has been absorbed. So what we're looking at is I'm going to try to match up. Is there a blip at 410? Oh, well, look at this. So if I go to 400, each one of these lines is 10, so 350, 60, 70, 80, 90, 400. So each line is 10. So technically this is going to be 410. So there I have my first example of, and so what I want you all to do is to point to that. That's 410, and that's going to be because of hydrogen. So that idea of, we know that hydrogen is actually part of the sun because that element is absorbing that particular wavelength. So let's keep going. So 486, so 450, 60, 70, 80. Oh, we're looking at the biggest. So this is 486, also going to be due to hydrogen. And this isn't a surprise because we actually know that stars, especially our younger stars, fuse starting at their hydrogen and then would be then fusing to helium. So our next one we want to look for is 656. Well, 656, there it is. So this is also going to be 656 hydrogen. So what you guys can do is work forwards or backwards. If you guys notice, there's different, so some of these blips are very small. Some of them are pretty large. So the larger the blip, the more element there is in the sun. So already we've actually, just by doing hydrogen, we know that most of the sun is going to be made up of hydrogen. So I'm going to let you guys finish up the assignment. And if you don't see a blip at that particular location, then that element is not there. So for instance, let's just go over here to the beryllium. So 558, if I go to 558, there's nothing here. So since there's no blip, no absorption, that means that there is no beryllium. The sun does not actually have any beryllium on there. So it would need to have both of these there. It would have to have the 558 and the 494. So you only actually have to test the first one to tell if that element is present in the sun. So then what you guys are going to be doing is, based on your analysis, you're going to rank the elements. So which ones did you find? Which is the most abundant? So we could probably say with certainty already, based on just doing the first one, that hydrogen is going to be our most abundant, and then you would just keep going from there. On the back side are just some questions for you to answer based on what you did here. Oh, one thing to point out, obviously when we're looking at remember our visible light is between the parameters of 400 nanometers and 700 nanometers. So, so that's, if you look at all of our numbers here, they're all within that spectrum. So have fun with your absorption of the spectra of the sun, and I'll see you guys tomorrow.